Okay, so we've been talking a little bit about the normal curve and some uh, frequency histograms. So I want to review that and talk about some of our measures of central tendency. One of the reasons that the mean, the median, and the mode are all called measures of central tendency is because when we have a normal curve, we find that they're in the center, but we have to remember the conceptual underpinnings of each of these concepts, okay? And so just for review here, remember this is an implied frequency axis here on for the y-axis. Here's our number line, okay? And we have, these are blocks under here. So these are people at this score with this frequency, right? We have this many people, and then there's people here. I mean, this whole thing is filled with blocks. That's what makes the normal curve, okay? And blocks up here as well. Again, review in a way. The highest point here is the most frequent, and so this ends up being the mode, right? If the normal curve is symmetrical about the vertical axis, then that means 50% of the blocks are here, 50% of the blocks are here, and so that ends up defining our median. The median is the place in the distribution where 50% of the blocks fall at or below. Okay? And then the mean was our new measure. The mean is our fulcrum, so it's that balance point. And it's really a physical balance point. I mean, if we created 100 blocks out of wood and put it on a plank and distributed them in this way, the mean would be right there. It would be the place that would actually balance the blocks. But we have to remember that it's balancing the blocks, but sometimes balancing the blocks doesn't mean that there's the same number of blocks on each side. Here's the example. This is what I want you to think about to make sure you can distinguish that, right? This is the mean of this distribution. 4 is the mean of this distribution. It's 2 plus 2 plus 2 plus 10, which is 16, divided by 4. That is the mean, okay? It's not the number of blocks. It is the deviations that it balances. So it's deviation minus 2, minus 2, minus 2, plus 6 here. And that's the only place for this distribution where you're going to have the equal deviations. All right? So let's think about some of these measures in these distributions. What would be the mode in this distribution? What would be the mode in this distribution? That's correct. The mode would be 2, right? Because that's the score that we see most often. Now, we have to be careful when we talk about the mode as a measure of central tendency. I'm going to put that in quotes, right? Central tendency, because in this distribution, this is the mode, and I'm not sure if that's the center of anything. I'm very careful. Let's keep with the concepts of each of these measures. The mode is the most frequent score. Wherever you see the highest point in the graph, that's the mode. Mean is the balance point. It balances the deviations, not necessarily the number of blocks. And by the way, for you folks that have taken physics, this is related to vectors. It's related to leverage, right? So even though this is just one block, the fact that it's further away, it carries more weight. The deviation is 6, okay? If you have a big fat person on the end of the teeter-totter, you could actually lift them up if you had a big enough lever, okay? So these mathematical concepts capture what's going on in the physical world, in the real world. And it's kind of cool to start seeing the relationships between all of these things across different disciplines. Anyway, where would the median be here in this distribution? Now, before, if you say, I don't know, remember, figure outable. Let's remind ourselves what the median is. The median is the place in this distribution where 50% of the scores fall at or below. Well, excuse me, we only have 4 people, so really I want to go to the place that where the first 2 people are at. Okay, that defines the bottom 50% of the people. If there's only 4 people, I need to go up to 2. So the median is going to be somewhere in this interval. Okay, I'm not exact. The mode is 2, the mean is 4. The median is somewhere in this interval, somewhere around 2. Okay, so now all of a sudden you're seeing the mode is 2, the mean is 4, and the median is, somewhere around 2. Now you're seeing an example where these measures start to differentiate. Okay, with a normal curve, unfortunately, they're at the same spot, and they're all referred to as measures of central tendency. And so I think it's confusing when you learn the concepts of these with a normal curve, because it can be misleading in a way. Okay. So let's do some other fun stuff, maybe. Okay. I'm going to erase this, give myself some room. Okay. So let's suppose that we take one of these blocks here. Here's somebody. So this person is at this score, whatever that score is. I want you to be able to abstract this stuff sometimes, right? I mean, I don't know what the score is. I could give you an example, but here's where they are, right? And what I'm going to do is I'm going to move this block. So I'm going to move this block. I mean, if you need an example, let's say the person has a score of 127, okay, right here. I'm going to, let's say, add 20 points to their score. I'm going to put them out here, okay, so I'm going to move them out to here, all right? So now they might have a score of 140. I don't know. It doesn't matter. I'm just increasing their score here. Here's a series of questions. If I move this block from here to here, what would that do to the mode? If I move the block from here to here, it wouldn't do anything to the mode, because here's the mode, and the mode is defined by the most frequent score. It doesn't matter. I move from here to here. I mean, this is going to go down a little bit. We're going to have a score out there. It doesn't affect the mode at all, okay, if I move from here to here. Okay, next question. Does it affect, how does moving this block from here to here, how would that affect the median? How would that affect the median? And the answer is, it wouldn't affect the median at all, because let's suppose there's 100 blocks here, even though it could be 627 blocks or 1,522 blocks, it just doesn't matter. If there were 100 blocks, we have 50 blocks on this side, 50 blocks on this side. If I move this from here to here, it doesn't do anything to the fact that we still have 50% of the blocks are at this point and below. Okay? So changing that number of that person doesn't do anything to the median. Changing this number for that person does nothing with the mode. Okay? Of course, the third question, if I change this person's score from here to here, what would that do to the mean? Okay, well, the mean is the balance point, right? The mean is the balance point. If I move this person from here to here, okay, so we were balanced, I move the person from here to here, what happens to the teeter-totter? it goes down, okay? So what do I need to do with my fulcrum? I need to move it over this way to move it back up, okay? So it was balanced, then I move that block from there to there, so it makes this side heavier, okay, because of the leverage, and then I have to move my fulcrum over. So the mean would be pulled out if I increase that score. Now, that's a concept, right? Let's go back to math, because in this case, maybe the math is easier, right? If this person started with a score of, what did I say, 127? If they started with a score of 127 and I say, oh no, I'm going to increase it to 140, if I add points to somebody's exam, the whole class average is going to go up a little bit, right? If instead of 127, a person's at 140, then I need to recalculate the average and it goes up. The mean is the only measure of these measures of central tendency. The mean is the only measure that takes into account every value of x. The mode doesn't. The mode doesn't care what's going on out here. It's just the highest column, right? The most frequent. So the mode doesn't matter if this was 127, 140, or 5,000. The mode is still right there, right? The median is just related to the lowest 50%, okay? So it doesn't matter. I could take a bunch of these blocks and move them upward, and it's not going to change the median. It's where 50% of the blocks fall at or below, okay? The mean is sensitive to any changes in the blocks, okay? So that would change the mean. The mean would be pulled out. If we move the block out, it's going to be pulled out that way, okay? Everybody with me? Think about this. Think this through a little bit, okay? Well, let's do another example. Let's take this block, and again, I want you to be able to understand that block is a person who has this score, right? And what I'm going to do is I'm going to say, well, let's move that block from here down to here, okay? So maybe they were at a score of 87, and we move them down to a score of 75, whatever it is. So let's go through these measures of central tendency, okay? Let's go through these measures of central tendency. What would happen if I move this score from here to here? What would happen to the mode? Hopefully this one was easier now, right? Nothing would happen to the mode. This is still the most frequent score, okay? In fact, we've taken one away from this column, so that drops a little bit. Put it down here, we should actually put it down here, right, on the, closer to the base. So nothing happens to the mode. What happens to the median? If I move this score from here to here, what happens to the median? Nothing happens to the median, okay? You're like, oh, I got that wrong. Well, let's think this through. Here are the bottom 50% of the blocks. This was in the bottom 50% of the block before. It's still in the bottom 50% of the blocks, and so nothing happens to the median, okay? If I move this block from here to here, what happens to the mean? Everybody got it? So it was balanced. Then I took this block and I moved it over here, so what happens to the teeter-totter? It goes down a little bit, right? In order to balance it, I need to move the mean this way to get it under again. Okay, so we started off balanced, then I moved the block, we went like this. I gotta move the fulcrum over to rebalance it. That is, if I decrease a score, then I'm going to decrease the mean. The mean is the only one of these measures that takes into account every single score. Okay, so if I change a value, the value of the mean would change. If I make this lower, the mean is going to be lower. Okay? See how these concepts work? Now, let's Let's do another one for fun. Isn't this fun? You're like, yeah, right. It's a lot of fun. What if I move this block from here to here? Okay. What would happen to the mode? That is correct. Nothing happens to the mode. This is still the most frequent, right? What happens to the median? Now, in this case, let's keep our wits about us here. If we had 100 blocks, 50% were over here, 50 of them were here, 50 of them are here. All of a sudden, I'm taking one of these 50 and I'm bringing it over here. So now there's 49 blocks here and 51 here. So what happens to the median? The median is going to shift a little bit this way, okay? If I cross that line, I'm disrupting this bottom 50%. It's becoming 49, so I need to move it up a little bit, okay? What happens to the mean? Balanced before, I increase this number. We have a change like this, so I need to move my fulcrum over, okay? So in this case now, the median and the mean would change. The mode would stay the same. And in a similar fashion, if I took this block and I moved it over here, mode would not change, right? The median now, since I'm taking one of the 50 blocks here and putting it over here, now I have 51. The median is going to shift slightly this way, okay, because I only want 50% of the blocks here. If I decrease any score in the distribution, I'm going to decrease the mean because it's now no longer balanced, okay? So that's how that works conceptually. Notice I haven't given you any information about the values of these scores. But if you understand the concept here of these three measures of central tendency, think it through, and you'll see how these things change. Okay? Now, before we talk even a little bit more about the measures of central tendency, I want to talk about some other curves that are common, that is frequency histograms, that are common enough that they actually have names. By far, the most common curve is the normal curve. Okay, that is the most ubiquitous of curves. But all of these curves depend on the on the nature of the variables that you're measuring, of course. Another kind of curve that's very common to see is something called a skewed distribution. Okay. Skewed with a K, okay, and it's not screwed, it's skewed, like a lampshade is askew, okay. And here's what a skewed distribution looks like. We have what looks like a normal curve, but then there's some extra, okay. Then there's some extra. Remember, and again, this is kind of not that difficult of a concept, but it's worth remembering that these are all blocks under here, right? And so what do we have? We have a situation where it looks kind of like a normal curve, right? Except we have extra blocks out here. We have extra blocks out here, okay? So these are our x values, right? These are our x values. And when we have a distribution where the tail is toward the right, okay, this is called a positively skewed distribution. Okay. And if I were to give you this on an exam, and I ask you, can you describe this distribution? If you said it's a skewed distribution, that's half credit, folks, okay? So I'm going to kind of expect you to give me the best answer, not just the okay answer. Is this a skewed distribution? Absolutely. But it's a positively skewed distribution when the tail goes to the right. Because we want to distinguish this kind of a skewed distribution from this kind of a skewed distribution, okay? Where it sort of looks like we have something that looks normal, but then we have extra blocks out here. There's a few more people on the low end of the continuum. And this one is called a negatively skewed distribution. Okay. And I hope that illustrates that, if you just say skewed distribution, that's not the best answer. Because if you told me you were looking at a skewed distribution, I wouldn't know if you were looking at a positively skewed distribution or a negatively skewed distribution. Okay. So, and whenever I look at these distributions, I sort of see this as looks kind of normal, but then extra in the upper end. That is, there are a few more people with higher scores than we would expect from a normal distribution. Okay. Over here, there's a few more people that are on the lower end of this distribution, making it negatively skewed than we would see in a normal. So when you talk about a skewed distribution, make sure you elaborate and say it's positively skewed or negatively skewed. Okay. Another kind of distribution that is not uncommon. Certainly it's not as common as a normal curve, but another distribution is called a bimodal distribution. And what we have in a bimodal distribution is what? Two modes, okay? So if we have a bimodal distribution, it might look something like this, okay? Sort of exaggerating that in a way, where here's a mode and here's a mode here, okay? So these are two modes. Remember, this is a frequency column, okay? And when I see this, I always think about two overlapping normal curves. So if we did heights for Utica College students and plotted those heights for Utica College students, we're likely to see a bimodal distribution. We're likely to see a bimodal distribution. Anybody know why that would be? If we did heights of college students at Utica College, heights of students, why it would be bimodal? Well, some of you got it right. This probably represents female. This probably represents a male, each of which might be normal. That is a normal curve. But we know that females tend to be less tall, not as tall as males. Even though there are some females, right? There are some females that are taller than some males, of course, okay? But in general, males are taller than females. So we would see this bimodal distribution, okay? Whenever I see a bimodal distribution, I'm always wondering if there are two populations underlying the data, okay? I remember years ago, I had a colleague in the psych department. She's retired, but she came to me one time. She said, "Steve, I'm really puzzled because most of my classes, when I give them an exam, they have, it's a normal curve." And that's actually true for lots of, when I give an exam, it's, a lot of times it's normal. Sometimes it's positively skewed. Sometimes it's negatively skewed. But she was teaching this class, and oftentimes she would get this bimodal distribution. And she was wondering why that was. And we talked about it. She knew statistics too, but she knew I taught statistics, so we were talking about why that might be. And we were talking a little bit about her exams, and she would give blue book exams, essays only. Okay, and this was like junior and senior level psych exam. And so she might have 6 or 7 essay questions worth 10 points. Okay, that's not unusual. And then we were talking, and what ended up happening was the way she was grading, I think, was contributing to her getting a bimodal distribution. And that is, even though every essay was worth 10 points, she tended to either give all or very little credit, right? So you either would get 8 or 9 or 10 points on your essay, or you'd get 1 or 2 points on your essay. So let's think about how this works, right? You're either getting most of the credit or you're getting hardly any of the credit. Well, what that ends up doing is it doesn't leave much available. Not many people are getting sort of 6s or 7s, or maybe a 10 and a 6 and a 4 and an 8 on their exams. They're sort of either getting 9s and 10s or 1s and 2s. And so when you put all that together, you end up getting this bimodal distribution. Okay, and this is another one of those things that I try to, throughout the semester, I try to emphasize with students. We're doing statistics because we want to understand what's going on, right? If we were doing heights of college students and we saw bimodal, I would expect females and males, right? This professor was getting bimodal distributions on her exam grades, and we sort of figured out, it's because people either knew the stuff or they didn't know the stuff. There's very little room for in the middle, okay? When I did my project in graduate school, when I was looking at psychobiology and neurochemistry in rats, we had a similar kind of a situation where we had a bimodal distribution, and we're trying to figure out, well, does this represent 2 different populations that are overlapping, okay? Even though it's one curve, it could be sort of 2 normal curves, okay? So we're trying to understand the world by the data that we see, all right? Sometimes people will describe a distribution like this as bimodal, okay? Now, technically, this is not bimodal, right? There's only one place where we have the most frequent score. Remember, these are scores here, okay? Technically, this is not bimodal, but you sometimes see these kinds of curves, and people will call them bimodal. If you're careful, what you would say is it's a major mode and a minor mode. I'm not sure that that's the best way to describe it, but anyway, this is not technically bimodal, but sometimes people will describe this. This kind of curve is actually not that uncommon with student test scores. And again, when I see any curve looks like this, I sort of think, is this a normal curve? Then with some added, something going on here. Remember, so now there's a few people out here, right, that don't fit the normal curve. And if I saw something like this, what I would think about is maybe this is a group of students who got together and formed a little study group, and they worked together answering questions or whatever, so that compared to the rest of the class, they're doing a little bit better, right? Or maybe these are students who are doing the homework problems at the end of the chapter as practice, and so that they're more prepared for the exam. I've seen that happen too, okay? So that these are students who are just sort of, coming to class and taking notes and not asking questions. These are the active students who are really participating, okay? We can also see something that might look like this. Again, This technically is not bimodal, but people often describe this because it's worth paying attention to this. And what I would kind of think here is maybe we have a normal curve, but now we have some people that are, some extra people here down at the bottom. And maybe this is, a semester where I have 5 or 6 students in my classes, and they're pledging fraternities and sororities, and I know that takes time away from their schoolwork, and so relative to this class, they're sort of, not doing as well as they could have or should have. Okay, so bimodal, technically this is bimodal when you have equal modes, but oftentimes people will talk about this as being bimodal. By far, the most ubiquitous is the normal curve, and by the time we get to chapter 7, we actually will, in some ways, guarantee our normal curve with a procedure that we'll do. But we have to deal with some of this as well. Okay. All right. So for a normal curve, the mean is here, the mode is here, the median is here. Okay. But now you guys are more sophisticated than high school students, thank God. That's why you're paying the big bucks, right? And you know that these are not synonyms. And you know situations where these values can be different for a distribution. And I want to talk about that a little bit more. Now, if you have a normal curve, the mean is sort of the gold standard for a measure of central tendency. By that I mean that's the best measure to use as a descriptor of central tendency if you have a normal curve. One of the reasons for that is because it's the only one of these that takes into account every score. Another reason is a lot of our statistical procedures are based on the mean and what is happening around the mean. And we'll get to that more later. So I want to sort of explain, why do we have these other measures, and when do we use the other measures? If the mean is the gold standard, shouldn't we use the mean all the time? And the answer is, well, we have to be careful, okay? If we have, let's say, a positively skewed distribution, do you remember what that looks like? I hope so. Okay, something like this. All right. If we have a positively skewed distribution, we have to be careful with the mean. If we have a negatively skewed distribution, we have to be careful with the mean, because remember, if we look at this distribution, we can sort of say, well, I know that that's the mode because it's the most frequent, right? And we'll get to the median afterwards. But where would the mean be? Well, if this was normal, the mean would be right here, okay? But for a skewed distribution, remember, we have a bunch of extra scores out here. We have a bunch of these extra scores, and so we have to, take those into account, and that's going to tip our teeter-totter this way. And so what happens is the mean gets pulled out this way, okay? Now all of a sudden, I get a little bit nervous thinking about this as the best descriptor of this data set, okay? If everybody got let's say we have a class of 10 students, and 9 of the students got a 70 or 72 on the exam, and 1 student got a 100, right? Are you with me? That would be a positively skewed distribution. There's somebody out there. That 100% is going to pull the mean out so that it doesn't describe the class very well, right? The average might be 82, There's nobody at 82. There's somebody at 100. There's a bunch of people in the 70s. There's nobody at 82. So we have to be careful about that. If you have a skewed distribution, the mean gets pulled out this way. But if you recall from when we were doing our, little thought experiments, moving the boxes, the median tends to be affected less. The median is affected less by an outlier like this, or a bunch of outliers when it's skewed. So the median is still going to be in here somewhere, even though the mean gets pulled out. So when we have a skewed distribution, people typically will use the median instead of the mean as a measure of central tendency when there's a skewed distribution. And that's true whether it's a positively skewed distribution or a negatively skewed distribution. The mean, if we have a negatively skewed distribution, the mean, rather than being here, is going to get pulled toward the skew. Okay? The median tends to be more stable and tends to be in this area. And our goal here, remember, we need to keep track of what we want to accomplish. We want to describe this data set. We want to describe the data set. And so if the mean gets pulled out here and it doesn't really describe the central portion of the distribution, then it's not a good measure of central tendency. Okay? Skewed distribution, I would rather use the median than the mean. Normal distribution, guess what? I'm absolutely going to use the mean. The mean is the gold standard unless there's a reason not to use the mean. Okay? Skewed distribution is a reason not to use the mean. Okay? What about a case where there's another case where we have where the median is used preferentially over the mean. And that is a situation that occurs more often than people want, and sometimes it can be avoided. Let's suppose that we're doing a research study where we want to look at the relationship between the number of siblings that you have and GPA. So we're going to ask students to indicate their GPA, and then let me know how many siblings you have. And so we'll do this in an IBM sheet, right? You're going to fill out the survey. And it says you either have 0 siblings, or 1, or 2, or 3, or 4, or more. Okay? And we do this survey, we do this research, and we get all of our data. And now I want to, do some descriptive statistics, and I'm going to figure out, well, what is the average number of siblings that Utica College students have, right? What is the average number of siblings? And can we get the average in this case? Well, yeah, right? So we're going to do this. We're going to get all of our numbers, and we'll do this and get an answer. And guess what? Impossible to do. And people are like, what do you mean impossible? Well, we have some people that say 0, some people that say 2, some people that say 2, 3, 1, 0, 4 plus. And I will ask you, what does 4 plus mean? Because it could mean 4, it could mean 5, it could mean 6, it could mean 8. And if you put this in your computer program and all the 4 pluses are just entered as 4, what's going to happen to your average? It's going to be artificially lower than it really is because you're putting in 4, even if the person has 5 siblings or 7 siblings or whatever it is. Okay? So this is a case where you have an undetermined value, so you really can't even do the mean. Can you do the median? Some of you might say, no, you can't do the median because you don't have all the numbers. Well, but let's remind ourselves, anytime I ask you a question about the median, remind yourself of what the median is, of course. Okay, remind yourself. So it's the point in the distribution where 50% of the scores fall at or below. Let's say we have 1,000 students in our study. As long as I can get to the 500th student before I get here, I can get the median. And I would bet, although I would have to rely on the data, okay? I'd have to rely on the actual data, but my bet is that we would get halfway through the respondents before we got to this point, okay? So the median in this case would actually be calculable where the mean wouldn't be. So when you have a case where there's undetermined scores, sometimes you can get the median, I mean sometimes you can't, but you certainly can't get the mean. I wonder what the mode would be here. We have to be careful with the mode too, because, I mean, you might say, oh, I think the mode would be 2, let's say, or maybe the mode would be 1. But remember, this includes not only 4, it includes 4 and all the 5s and all the 6s and all the 9s and all the 10s. Oh my gosh, big family. And all the 7s and so on and so forth. So this category is going to have more people than just the 4 because you're putting everybody into that bucket. Okay. This issue came up when I was in graduate school because I was studying drinking behavior, ingestive behaviors in rats, water drinking, and I would measure how much they drank in an hour-long test. But I also would keep track of when did they first start drinking. And that's called latency to drink. And so it's an hour-long test, so it's 60 minutes. So some rats would drink after 10 minutes, and some rats would drink after 8 minutes, and some rats would drink after 23 minutes, and some rats would drink after 19 minutes, and some rats wouldn't drink for the whole hour. So it's 60 minutes plus. Some rats would drink at 43. Some rats would drink at 60 plus, okay? Some rats would drink at 23 minutes. Some rats would drink at 17 minutes, okay? What do we have there? 10 rats. 3 of them did not drink in the hour. If I put 60 in for those rats, that's not really accurate because maybe this rat would have drank at 60, maybe it would have drank at 65, or maybe it would have drank at 103 minutes. So I really don't know. And so this is an undetermined value as well. And what we did in this case is we used the median. Can we get the median? Well, if there's 10 rats, I want to go from the lowest number and work my way up to the 5th number, right? So 1, 2, 3, 4, 5, somewhere around 23 minutes would be the median, okay? Somewhere around 23 minutes would be the median. So we can calculate the median, no way to calculate the mean. If I put 60 in there, that would artificially decrease my mean because they didn't drink at 60. They might have drank, later. Okay? Skewed distribution, use the median. Undetermined values, use the median if you can. Normal curve, mean, mean, mean. That's the gold standard. Okay? All right, well, we're left with when do you use the mode? Well, the mode is very fickle. The mode is very fickle, folks. I mean, we could have a distribution that looks something like this. Let's do this. Remember, these are x values. This is frequency, right? where's the mode in this case? Well, the mode is here. That's the most frequent. Is that a measure of the central portion of this distribution? Absolutely not. Absolutely not. In fact, it's at the very far end. So I actually don't like when people call the mode a measure of central tendency. I'm doing air quotes there. It's in the center for a normal curve, but that's just coincidental because the concept has nothing to do with anything to do with central. It has to do with most frequent, okay? And that can pop up at different places. So the mode is fickle. However, there's a couple of situations where the mode is the preferred measure or the only measure. I mean, if we go back to our chocolate, vanilla, and strawberry, if we have categorical data, then the mode is the only measure, right? Most people pick chocolate, some people pick vanilla, other people, this is the mode. Can we get the average for the average flavor? The answer is no. It doesn't make any sense. We can't add and divide by the number of people. Can we get the median? We absolutely cannot get the median in categorical data because vanilla could be first or strawberry could be first. I mean, there's no order of these categories. So in categorical data, the mode is all that we have, okay? But let's look at something that's not categorical, where the mode might be useful, and that is let's make this a nice symmetrical, we're going to make this a symmetrical bimodal distribution. If it's symmetrical, right, and 50% is here, 50% is here, here's it's symmetrical around the vertical axis. So we know the median would be here, right? 50% at or below, 50% at or below, okay? So we know the median is there. If this is purely symmetrical, let's do our fulcrum here. So we know the mean is here. Keep your goal in mind. I want to describe this data set. If I use the mean to describe it, this number, boy, is it the balance point? Yes. Is the median here? Yes. But it doesn't tell me much about what's going on out here, right? And so it's not a very good descriptor. So if I have a distribution like this, I'm going to say it's bimodal with a mode here and a mode here. By the way, I'm still going to give you the mean and the median, okay? But the mode becomes helpful in this case, all right? I mean, this would be, I could make an exaggerated example. If everybody got, if half the students in the class, I mean, let's do this as an exaggerated example. Half the students in the class got 60% on the exam, and half the students in the class got 80% on the exam. If I were to calculate the mean for this distribution, the mean would be 70. If I came into class and I said the mean on the exam was 70, and people are like, oh, okay. Does this describe this distribution very well? The answer is no, it doesn't. In fact, nobody got 70. And I would be better off describing it and saying 60, there's a mode at 60% and a mode at 80% with the mean of 70. Okay. Again, this harkens back to something we talked about several videos ago. When somebody reports the mean to you, you have to be careful. A mean of 70 could mean everybody got 70. A mean of 70 could look something like this, or a mean of 70 could be from a distribution like this, okay? If we make the assumption that the distribution looks like this, then the mean is a good descriptor. if that assumption is not correct, then we can run into trouble. Okay. One more thing, because now I want to go in the sort of not the opposite direction, but another direction. If your computer printout, because oftentimes you don't see the graph. Your computer printout says this: the mean is 75, the median is 75, the mode is 75. Then that's a good indication that we have a normal curve. Okay? Now, you're rarely going to get something that clean. I mean, if you have something like this, 75.17 and 74.45 and the mode of 76, I mean, those are close enough that we can say, wow, that looks sort of normal. What if you had a computer printout that said this? And people are like, yeah, what if I did? Right? I mean, so what? Well, this is an indication that we have a positively skewed distribution. Right? Remember? We have to be willing to sort of say, when we have something like this, what happens is the mean gets pulled out to a higher level than the median and the mode. So this would give me an indication that we have a positively skewed distribution, just from the computer printout. If the computer printout was something like this, you know, I don't always want to do test score examples, because when you're a professional, you're going to be looking at all sorts of different data. Okay. Well, what does this look like? Well, these are pretty close together, and then this is lower. And so that gives me an indication that maybe I have a negatively skewed distribution. I mean, you're typically not required to pick one of these, and oftentimes, you know, I'll report all three. But I just want you to be fully aware that these measures can separate, and I want you to see, you know, what the curves look like when they do separate. They are absolutely not synonyms. Okay. We'll use a real-life example to start off our next video, and then talk about weighted means, and then we're going to be through chapter 3. So make sure you're reading the book as well. And again, as always, email me if you have questions.